So here's the part of the video that is explaining all the IntelliJ tools and hacks that I also demonstrated alongside the debugging workshop. So basically when I was presenting the code, this was the part of the workshop that taught them these tools and then encouraged them to use it while they debug the actual project themselves. I think most students found this probably the most useful just because it's a very concrete takeaway from the project or from the workshop. And it helps with productivity in not just this project, but any project they're looking at through IntelliJ. So the main point of this is just for you to be able to use IntelliJ more than just text editor, because it has a lot of extra functionality, because it indexes all of the classes. It records what variable is defined where. So first thing that I want to show you is the idea of control clicks or command clicks if you're on a Mac. So I'm on Windows, but if you hold control or command and then click on a variable, it'll actually bring you to the exact position where that variable was defined. So this is a variable called dirs. It's a static class variable, and it's defined up here. But if I go back to where I just came from, I can basically click anywhere in the code, and it'll bring me to a function or a variable definition. So currently I'm calling a method called +dir. So if I control click plus, I come to the actual definition of where that plus method was defined. Now, the other command I'm using in conjunction with this is control alt left and control alt right. If you're on Mac, that's going to be command option left, command option right. What that does is it brings you to your previous or next cursor position. So if I do control click plus, I'm at this new location. If I do control alt back, it brings me to my previous cursor location, which is the actual part of code I was reading. If I go forward, that's the actual definition. And these two things by themselves are very useful just to read code. So for example, if I'm reading this check win function and there's a lot of code and it references a lot of different parts of the code, if there's any function that I don't understand, I can just control click, and then after I read the function, I can just control alt left or command option left, and I go back to exactly where I was before. So that's some quick tips. And the control click or command click is actually really useful. So even it does a bit more than just navigating. So if I click this say list valid position, so here's a method. So I'm already at the definition, but I can still command click that function name again. If I click it again at the place where it's defined, not just where it's used, it actually lists every location that it's used inside of your project. So here I see it's used 3 times within tic-tac-toe board.java, and it's used a bunch of times inside the tests. And you can click any one of these and it brings you to that location. So that's really useful in case that you want to see oh, what is this valid move function? Where is it used? And you can see how it's used, stuff like that. Super useful. So those are probably the bread and butter of IntelliJ in terms of getting people started on using it more like a Wikipedia page, because there's a lot of links and a lot of connections. Here's a couple of extra shortcuts that are not always necessary, but pretty useful. So there's obviously Control F to just find stuff in your current document, but you can also do Control Shift F. So Control Shift F will give you a project wide control find function. So I can search for maybe public class pause. So it'll find it somewhere in the project. And then say I wanted to look for check win. I see that it searched basically every single file that has the string check win. And then if you click on one of these options, you can see a preview of where in the code you're actually looking at, just to quickly search. So if you have a big project, that's really useful. So that's Control Shift F or Command Shift F on Mac. Next is a function to basically close. Basically, there's a lot of text here, and say you only want to read the headers for each method. It's kind of hard to scroll down and filter through all this. So sometimes you can use Control Shift minus or Command Shift minus, and basically this will collapse all of the code blocks. So if I look at check win, check-when was a super long function, but if I start clicking into it, I see that all of these while loops and the actual function itself was collapsed into a very readable form. So that's Control Shift minus to collapse everything. Control Shift plus makes everything bigger. If you only want to make one of them bigger, you can, so if I click on this check-when and I only want check-when to expand, I can do Control Alt plus, and only check-when will expand. But usually when I'm reading, or at least presenting this document, I'll probably do Control Shift minus, and then I'll basically read out all the functions, and then tell you like, oh, this one is this, here's some getter methods. It's a good way to just overview an entire class without really looking into the code. And then if there's a one point of interest, which is like check-when, check-when's like a pretty important function for all the bugs, you can do Control Alt plus, and then everything will be opened, and then you can just read it as normal. Next thing is, this is just for simple productivity. If you're working with a lot of code and you want to like cross-reference different parts of your file, if you click on the tab itself, you can right-click and then split vertically, and then you have basically two copies of the code, left side and right side, and you can play around with that. That way you can like reference and copy and paste as much as you'd like. As everyone know, coding is just copy and paste, but this way makes it a bit easier on you. Cool. And then last thing, in terms of navigation, I'll have a separate portion on just using the debugger and the debugger functions. Is basically IntelliJ can pretty much do like anything you can imagine. That's not like a complete promise, but like oftentimes if you can think of a function, IntelliJ probably has it built in. You just kind of have to know how to look for it. Google is a great way to figure this out. But another way is also you can right click. So what I did before was if you control click or command click a variable or function definition, like this one, it lists all the usages. But if you forget how to get that, you can also just right click. So if you right click, you have a bunch of different options. So you have find usages. That's exactly what I just did. This one's a bit different because it has like a little extra window that opens at the bottom, but it does the same thing. It shows you all of the places where check-when is used. If I right click again, you can do refactor. If you click refactor and then you click rename, it renames basically every instance of this check-when function. This is really useful because sometimes I put in a really bad name and then like halfway through the project I realize, oh, I should change this name, but it's hard to track down everywhere you used the variable. So IntelliJ makes that super easy with this refactor. You can change signature. There's a bunch of cool stuff in here. I guess it's kind of dumb to say it's cool, but like it's very cool if you're like coding a lot and then you really want to like be very nitpicky. IntelliJ makes it really easy. Just rename stuff, make stuff like look nicer. Yeah, so I'd really recommend that you explore this right-click function because you can do so much with it. But yeah, that is it for the navigation portion. Okay, so this is the IntelliJ tutorial part that explains all of the debugger stuff. So this is basically talking about how to set breakpoints, navigate through the code, and then use some of the debugger tools to help you like inspect the code. A lot of students are not familiar with this, mainly because they usually use print debugging, or they aren't just familiar with how IntelliJ works or how the debugger works. So be very slow and careful and make sure that like no part is unexplained, because some people will come in to this workshop with like no knowledge of how the debugger works. So first things first is IntelliJ needs to run all of the JUnit tests. So this project has some provided JUnit tests in tic-tac-toe board test. You want to run all of these, but you can just click run, but that kind of doesn't format it properly. If you run this create, but basically you go to that test. On the left there's this run button. You click it and you click create tic-tac-toe board test. This allows IntelliJ, once you click run, to basically process this entire file as a JUnit test. So it does this organization. It does a lot of stuff for you. It separates all of the outputs of all the tests, and then it tells you which ones failed and which ones did not. And then first things first is you kind of want to inspect the actual function that failed. So I can click this link and it'll actually bring me to the actual position inside of that test that initially failed. And then so over here you see that this line is an assertion statement, and that assertion statement basically wasn't met. So this is assert true. I'm guessing whatever was inside of here returned false. Now, say we want to debug this function. First thing you want to do is set a breakpoint. So if you click between the numbers and the actual line of code, right in between, you can set a red breakpoint. And then once you click debug, it will start running your code, and then it'll stop at the very first breakpoint it hits. So if you go inside like a different function, and then you like set a breakpoint somewhere, next time you run the code, the very first time you hit that function, it'll actually go into that breakpoint. So you want to be careful with where you put breakpoints, and you always want to be aware of where in the code you actually are. Because later on, if I'm inside of like, say, this check-win function, and I set a breakpoint, say, here, if the code line is stopped here, you want to make sure you're 100% sure of where you came from, as in, did I come from this check-win test? Did I come from the valid position test? I could be anywhere in the tests, and a good way to check that is, okay, so I set this breakpoint, so if I click resume, it'll keep running until I hit another breakpoint. And the next breakpoint I hit was the one inside of my check-win function. And over here on the left, you actually see a call stack. So if I click 1 above it, I actually see this is the line that called check-win. So you see that check-win right here. So I can see where did my current function call come from. And basically tells you where did you come from, right? And then if I go back, this is where I currently am. So always be aware of where you are, because otherwise you sort of lose a lot of meaning in what code you're looking at, just because if you're in the wrong position, the variables you might look at might be completely correct because you're not in a function that's returning something incorrectly. Okay, so back to the beginning. Let us get rid of this breakpoint. I'm going to hit the debugger again, and I'm currently at the top of check-win. So first things first, in order to navigate the code, is the step over button. What that does is it executes the current line and moves you one line down. So same thing here. I created a tic-tac-toe board. I ran it again. I set player to 1, and there's little messages up here that will tell you like some relevant information. But that's the main way to like navigate your current function. But say I want to go inside a function that's currently being called. So on this line, there are 3 different functions. There is this assert false function, there's a check win function, there's a position constructor. Say I want to inspect one of those functions. I can click this step into, and that displays these 3 different functions, and I can click one of them, so like check win, and I go to the very first line of check win. And then, yeah, so, and then let's say I do some step overs, I inspect the variables, everything looks good, and I just want to go back to where I came from. I can click this step out, and step out finishes the current function you're currently in. So right now I'm in check win, and then it finishes all of that, and it returns me to where I was before. So right now I've just completed check win. If I click step over, I'll be 1 step over, right? Okay, so those are the basic like navigation skills. If I really want to go to a specific location, so let's say I'm inside of, let's go to check win. So I'll do 2 step overs and then I step into, and I'm inside of check win. Let's say I really want to inspect this if case, right? I want to see what it looks like when I get to that if case. And let's say there's a lot of while loops here, and I don't really want to like hit this step over button like 100 times. You can just set a breakpoint down here and then click resume program. And what resume program does is it basically runs all of the code as if it was like a regular run, and it'll stop at the very first breakpoint. So now it's stopped here, and you can inspect the code. One thing to do is like make sure you remove the breakpoint, because later on, if I'm running, if I'm trying to like debug other code, I might get stuck here, and I won't really know why I got stuck here or where I came from. So it might just be confusing. But if you're doing this one-time jump, just remember to remove it once you get here. Okay. So that's the main way to get to certain points in the code. So the idea is so this navigation basically brings you to certain places in the code. And the next question is, okay, now that I'm here in the code, what should I do? And that's kind of dependent on the bug that you're trying to solve. But the main answer is I want to look at these watches. So everything down here, all of this stuff, these are watches. What that means is if I like double click at this, it gives me all of the current variable information. So like if you're drawing an environment diagram, these are all of the variables in the current frame. And you can even look at things out of frame. If you go one step up, you can actually look at all of the variables in the parent frame or the parent frame. Right now there's only 2 frames, but in theory you could do that if there was more frames. And then these watches are actually really powerful. They basically allow you to analyze any variable. It even allows you to analyze function calls. So one thing to do is if I click this plus button, you can start typing variable names. So maybe like this, and you can even call functions inside of this. So here's a display board string function. So what that does is this is a function in the current object that will output like a string that represents the tic-tac-toe board. And it's really nice to view the board, and if I click this view button, it gives me a little image of all the text in like its formatted position. So you can call functions, you can do different operations on functions. So you can do like player plus this dot n, stuff like this. Like you can do a bunch of different operations. So any variable you want to analyze, you can put it here, and then next time you click step over, all of these watches that you've created, they'll stay constant, or they will always be here, but they'll update based off of the new values. So if I click step over and it updates something inside of this.n, it'll update this watch. So you'll always have the correct values. So if there's something you're watching, you can just keep clicking step over and see if it changes the way that you want it. Okay, last thing that I forgot to mention was there's another thing called basically conditional breakpoints. So if I'm currently in the code, and let's say I want to go to check win, and there's a very important variable called this streak count. Basically streak count basically determines whether or not we have a win. So that's like a very important thing for this make move or check win function. Basically it updates whether or not there's a win. If I want to only stop at this if statement for certain values of streak count, I can right click that breakpoint and I can basically type in any boolean, any expression that evaluates to a boolean. So I can have like streak count is greater than or equal to 2. So stuff like that. So now if I run this code, I'm not 100% sure if there will be a case where it is greater than or equal to 2. But if I click resume program, oh, there is. Okay, so I see that I now have stopped at this breakpoint, and because of the condition I set, if I actually look at streak count, it's now the value of 2. So it will only stop here if that is the case. That way you can filter out really like boring cases and like only go to the edge cases that you're like really focused on. So it's also useful if you have like a for loop that like iterates through a bunch of numbers, and it only happens to fail on like when I equals like 212. You're not going to click step over for 212 times. The best way to do it is just use a conditional breakpoint. So yeah, just another navigation tip for you.